Hello everyone, my name is Jacqueline Relaford and today I'll be working with a special guest, Red the M&M. So today I'll be testing for two different things. The first is I'll be testing for the claim that the M&M company has that says that 0.13 or 13% of M&Ms are brown. The claim will be P equals 0.13, which also happens to be our null hypothesis, and our opposition will be P does not equal 0.13, which happens to be our alternative. So the first group will have 400 total m&ms across 40 trials, and the second group will have 800 total m&ms across 40 trials. In my second objective, I'll be testing how many of our M&M sample trials fall in the population proportion of brown candies. In other words, are 95% of the confidence intervals falling within P equals 0.13. So let's have Red show us that a little bit more. So our population will be 0.13, and that's going to be the true population. Our claim will be P equals 0.13, and our opposition will be P does not equal 0.13. And this will be a two-tailed test because we have an equals and does not equal. So beginning with group 1, we did 40 trials of 10 M&Ms, and we counted all the brown ones. After counting all the brown M&Ms, we decided to make a graph showing the true population designated by the vertical black line and showing the confidence intervals of the 40 trials. Starting from the left side, we have a true parameter of 0.13. We had 32 trials that contain that true parameter. We had a total number of trials of 40, and we had a 0.80% of our groups containing that true parameter with a target level of 95% confidence. So Red is going to help us determine whether or not we're going to use a z-score or t-score. Correct. So we're going to use the z-score. Oh, I hope Red didn't get too hurt back there. So moving on to testing the claim. So of the first 400 total M&Ms in sample group 1, 53 of them were brown. Test the claim that the proportion of brown M&Ms is equal to what the M&M company stated about the population. Use 95% confidence interval with the 0.05 significance level. So once again, we have our null and alternative hypothesis listed. And then we calculated our z-score, which came out to be 0.1487, and a p-value of 0.88, which gave us our conclusion. So because the p-value is greater than our significance level of 0.05, then we fail to reject H of O. There is not enough evidence to justify rejection of the claim that the proportion of brown candies is equal to 0.13. So here's how we calculated the z-score. Take note of how we calculated p hat, which is signified by x over n. So moving forward to our second group, we have n equals 20, and we did, once again, 40 trials and counted the brown candies. We then came up with another graph that showed similar things, but take note of how the proportion here is just a bit higher with 0.825 compared to our first group, who only had 0.80. So for group 2, we're asking the same question, but our n changes from 400 to 800, and 95 of them were brown. We have our claim and our opposition in the same place. Our z statistic came out to be negative 94.62, and our p-value 0.34. So our conclusion states that because the p-value is greater than our significance level, then we fail to reject H of O. There is not enough evidence to justify rejection of the claim that the proportion of brown M&Ms is equal to 0.13. And then once again, here's the work for how we calculated our z-stat. So now that we've graphed everything and calculated our z-stats and our p-values and came to many different conclusions, we have our second question. How many of our M&M sample trials fall in the population proportion of brown candies? Is it at least 95% of them from each group? So some trends that I noticed is that increasing the sample size from 10 to 20 actually resulted in an increase in the number of trials that contain the true proportion. Even though it was a small change, it still happened. However, the larger sample size had an increase the chances of randomly picking a brown M&M. So our final statement for this project will be both groups did not have at least 95% of their trials within the true population. The first group, in a sample of 40 trials, only 80% of them were within the true population. And in the second group, only 82.5% of them were within the true population. Also, Red told me to tell you all that he's doing well. Thank you all for listening.